We are talking about simplifying radicals. We want to simplify radicals in different forms and use conjugate pairs to simplify radicals. So here we have the square root of 2 divided by 5. And the issue is we don't like having a radical in the denominator. And even though it doesn't look like it, this radical goes with the 2 and it also goes with the 5. So we can rewrite this as the square root of 2 divided by the square root of 5. So in order to get rid of that square root of 5 in the denominator, we have to multiply by the square root of 5 over the square root of 5. Now, the reason that this is okay to do is because we're not changing the value of this fraction, because we remember that the square root of 5 over the square root of 5 is actually just equal to 1. So all we're really multiplying this by is 1. So we're just going to change the way it looks, but we're not going to actually change the value. So we get the square root of 2 times the square root of 5, and it stays under the radical because it's still the square root. And then we get the square root of 5 times the square root of 5. Now, the index number, if it's not written, is understood that there is a 2 sitting on the outside of the radical. That's the index number, that's a 2. And same thing down here. If there's no number written, we understand that there's a 2 there. I should write that a little. We don't have to write it down if it's square. We only have to write it down if it's 3, 4, 5, 6, 7. So if it's not written down, we understand that there's a 2 there. And in order to take things out of the radical, we have to have that same number. We have to have matching pairs in this case. So we have to have 2 of whatever in order to bring it out of the radical. In this case, we look at the numerator. We have 1, 2, and we have 1, 5. We don't have a pair. We can't take anything out of the radical, so we just have to multiply those together. So in this case, we get 2 times 5, which is 10. Now in the denominator, we have 5 times 5. That's a pair. So we can take this pair out. We can take that pair out of the radical, and there's nothing left under the radical, so that's a perfect square. So then we're just left with the square root of 10 over 5. Now we can look at example 4. And example 4 looks a little different because we have this operation of plus in the denominator, and we also have the radical in the denominator. So in order to get rid of that, what we have to do is we have to multiply by the conjugate pair. So the original says 6 divided by 2 plus the square root of 2. Now, in order to get rid of this denominator, we have to multiply by the conjugate pair, which in this case is we want to keep the terms the same. So we still have the 2 and we still have the square root of 2. Now we just have to change the sign. In order to not change the value of this original fraction, then we have to, whatever we put in the denominator has to be the same in the numerator. So this is actually just equal to 1, right? 2 minus the square root of 2 divided by 2 minus the square root of 2. It looks really the value of that is just 1. So in the numerator, we take 6 and we multiply it by 2. So then we get 12. And we take 6 and we multiply it by negative square root of 2. So we get negative 6 square root of 2. And then in the denominator, we get 2 times 2, which is 4. And then we get 2 times negative square root of 2, which is negative 2 square root of 2. Then we take the square root of 2 and we multiply it by 2, which becomes positive 2 square root of 2. And then we take 2 and we multiply it by, or excuse me, the square root of 2, and we multiply it by negative square root of 2. So we get negative square root of 4. Then we can write that down. Can't do anything with the numerator. That just stays as it is. So that's 12 minus 6 square root of 2. And what happens with our denominator, and this is the reason why we're multiplying by the conjugate pair, because we have a negative 2 square root of 2 and we have a positive 2 square root of 2. So those cancel each other out. And so we're just left with 4. And we know the square root of 4 is 2. So 4 minus 2. And that is going to be equal to, can't do anything with the numerator still. So that's going to be 12 minus 6 square root of 2. 4 minus 2 is 2. And so we can divide everything by 2. So 2 divides the second term, and 2 divides the first term. So 12 divided by 2, and 6 divided by 2, and 2 divided by 2. Twelve divided by 2 is 6, minus 6 divided by 2 is 3, and 2 divided by 2 is 1, so we don't have to write that down. So our final answer is 6 minus 3 square root of 2. Then we can look at example 3 here. And the issue is that we have square root of 7 in the denominator. So we want to get rid of that. So what we want to do is, in the denominator, well, we'll just write it down right over here. In the numerator, we can split this up and we can say that is equal to the square root of 4 times the square root of 3. Then we have, in the denominator, we have 2 times the square root of 7. We don't like the square root of 7 in the denominator, and we need to get rid of that. Now, there is a 2 that comes with it in the denominator, but we don't have to multiply by that to get rid of it, because we're okay with the integer being in the denominator. So we're going to multiply by the square root of 7 over the square root of 7. And the reason that we can do that is because that is equal to 1. So that's not going to change our value at all. So we know that the square root of 4 is 2. So we can write as 2. And then we have 3 times 7. That's the square root of 3 times 7 under the same radical. And over here, we have 2 times the square root of 7 times 7. So now we can look at really simplifying this. We have a 2 in the numerator. We have a 2 in the denominator. Those cancel each other out. Now we remember that there is an understood 2 that sits right there. So if we have a pair underneath the radical, we can take it out as 1. But we have 1, 3 and 1, 7. We don't have any pairs. So what that just has to stay as, multiply that together, and we get the square root of 21. Now in the denominator, we do have 2 7s, and so we can pull that out. So we get the square root of 21 over 7. Then we have another example where we have the radical in the denominator along with an operation of subtraction. So in order to solve this one, we have to use our conjugate pairs again. So in order to set this up, I'll just write down the original. So we have 4 divided by 3 minus 3 square root of 5. Now we want to multiply by the conjugate pair. And we're also going to have to multiply by 1. So we get 3. We had minus originally, so now we have to do addition. And in order to make sure that we're not changing the value here, whatever we put in the denominator, we have to put in the numerator. So 3 plus 3 times the square root of 5. So when we do this multiplication, we get 4 times 3 is 12. And 4 times 3 square root of 5 is plus 12 square root of 5. Then in the denominator, we can say 3 times 3 is 9. And 3 times 3 square root of 5 is 9 square root of 5. Then we can say negative 3 square root of 5 times 3 is negative 9 square root of 5. And negative 3 square root of 5 times 3 square root of 5 is negative 9 times the square root of 25. So in the numerator, we can't do anything there, but in the denominator, we have a 9 square root of 5 positive and a 9 square root of 5 negative, and those cancel each other out. Also, we know that the square root of 25 is 5. So this is actually 9 times 5. So we can start reducing this a little bit. So here we have, in the numerator, we're going to say 12 plus 12 square root of 5. Then we have 9, and then minus 9 times 5, which is 45. And we can reduce this a little further. 9 minus 45 is 36. So we get 12 plus 12 square root of 5 divided by negative 36. And now we can see, do we have anything in common? And here we do have something in common between the numerator and the denominator. So we can divide everything. We have a 12 and a 12 and another 36 that can also be divided by 12. So we can divide all of these by 12. And then we get 12 divided by 12 is 1. 12 divided by 12 is 1. And then we still have the square root of 5. And then we have the negative 36 divided by 12 is 3. And then the last thing, we don't like having a negative in the denominator, so we want to get rid of that. And so we can distribute the negative to the numerator. So then we have negative 1 minus the square root of 5 over 3.